Hello everyone, welcome to this lecture. In this lecture, I'll be covering the rest of the physical properties of alkanes. In the previous lecture, I have covered the topic boiling point, melting point, and physical state. And everything related to melting and boiling point is covered in the previous lecture. So kindly go through the previous lecture first. Now in this lecture, quickly we are going to proceed ahead with the next topic, that is density. Now when I talk about the density of alkanes, remember alkanes they have very low density, and the density it increases from lower alkanes to higher alkanes. So as the carbon atom goes on increasing, the density also goes on increasing, because we know that density is nothing but it is mass upon volume. If the mass is increasing, definitely density will also go on increasing. Clear? And then alkanes, they are what? They are lighter than water. Proceeding ahead with the next topic, solubility. Alkanes are non-polar compound. Already in the previous lecture, we have covered entirely about alkanes, why they are non-polar, right? So everything we have covered. So alkanes are basically what, students? They are non-polar in nature, right? And then the dipole moment of alkanes, it is what? It is almost a zero. Okay, it is dipole moment is zero. Now, why the dipole moment is zero? Because alkanes are non-polar, and whichever is non-polar, the dipole moment becomes zero. Okay, and when I talk about the solubility, always remember very important point, that is like dissolves like. Okay, now what do you mean by this term? Like dissolves like. Okay, I'll write down here. It is very important. Now, like dissolves like means if there is a polar, so polar it is going to get dissolved in polar molecule. Whereas a non-polar, it is going to get dissolved in a non-polar molecule. Okay, that means the similar type of compounds will be getting dissolved. For example, polar into polar and non-polar into non-polar. When I talk about alkenes are basically non-polar, right? So they are not going to be soluble in polar solvent. Remember, the alkanes, they are what? Since they are non-polar, they are not going to dissolve or get soluble in water. Because water is what? It is a polar solvent. So rather alkanes, it will be soluble in non-polar solvents like ether, then benzene, carbon tetrachloride, and so on. Okay. Now, the solubility of the alkenes in any solvent, it decreases with the increase in molecular mass. Now, if I talk about the solubility, as the molecular mass increases, the solubility, it goes on decreasing. Okay. Now, why is it so? Definitely, if the chain it goes on increasing, if the chain goes on increasing, then it becomes a difficult for a compound to form the bond. Okay, so it becomes a difficult to form what? To form the bond with the other molecule or to form the hydrogen bond. So basically, I can say that solubility formula, it will be opposite to boiling point. So solubility, it is inversely proportional to molecular size. More the number of carbon atom, lesser will be the solubility, because more the number of carbon atom, then to form the bond or to form the hydrogen bond, it becomes very difficult. On the other hand, if the size or if the structure is compact, if there is more branching, okay, so it becomes a little easy to form a bond. So solubility, I can say that it is directly proportional to branching. Okay, so solubility directly proportional to branching, and it is inversely proportional to molecular size. Clear? So this is the entire concept related to solubility and density. Now we are going to solve few questions on the same topic. So quickly take out your notebook and start solving with me. I hope the topic based on the physical properties of alkanes is clear to you. Still, if you have any doubt, any difficulty, then you can ask me in the next lecture. I'm here to clear all your doubts. In the next lecture, I'm going to proceed ahead with the next topic, that is chemical properties of alkenes. So keep watching all the lectures and I'll see you in the next lecture. Till then, bye-bye.